another Leetcode problem. 1236, a web crawler. So before solving this problem, you have to ask yourself, do you know what is a web crawler? Or have you ever written a project by using the web crawler? Yeah, because currently the generative AI is really popular, like the chatbot or like ChatGPT, and definitely they used the web crawler to build the project. Yeah, so if you've ever written a project with the web crawler, normally this problem is going to be really easy because this is just a very small part of your project, like a chatbot. Basically, you want to crawl all the website. So how can you crawl the website? You're gonna write a web crawler. Yeah. So now let's just try to understand. So for the web crawler, we're gonna use a start URL and we're gonna use the HTML parser. So for this HTML parser, it is just a method. It is hide behind our class. So for our class, we can use this HTML parser. So it is an object, and we're gonna have a method get URL. So we can, by using the start URL, or we can use any URL and pass it into the get URLs with this method, and we can return a list of URLs. So this is just the basics. Yeah. So for the idea of a HTML parser is that if you are giving a HTML file, so inside the HTML file, there can be any kind of links. So for example, inside the HTML file, it can be this link or this link, and this HTML parser can directly get all those links for you, and you can use it directly. Yeah. And if it is a web crawler, what kind of algorithm are we gonna use to write this web crawler? Of course, it is gonna be a BFS. And for our problem, it's gonna be a single source BFS because there's only start URL. While I'm running my web crawler, it's gonna be a multi-source URL, multi-source BFS because it's gonna have many start URLs. Yeah. And there's also a pattern we need to understand. So for this problem, you know, if it is http leetcode.com.problems, yeah, if this is the start URL, we need to have an include pattern. So normally in the project, we're gonna write an include pattern. So the include pattern gonna be the http leetcode.com. So this gonna be a pattern. Yeah, and this is also the host name. So for all the URLs, it should include this pattern. So include the host name. So this is the host name, but we need to include this HTTP, yeah, with the host name. But we don't need to have this port number. Yeah, because for most of them, they don't have this port number. So this is why there are so many descriptions, but basically this is just a very simple web crawler. Yeah. Now let's just check the examples maybe. Yeah, so inside the examples, the input is kind of like URLs and addresses and start URL. But we don't have such kind of URLs and addresses. We only have start URL. Yeah, but this is just for easy for us to understand. Actually, we don't need that because we have this HTML parser. If we pass a URL, definitely we can get all those URLs. So we can ignore the address and URLs because basically that is not related to this problem. Basically, we don't need it. We only need to take care what is the start URL and what is the output. As we can see from the output. So if the start URL is this domain with news and topics, and here we have this domain, this means from the HTML parser we got this domain, and we got some kind of other URLs. Basically, they are pages, and we crawl such kind of pages, and this is going to be our final return. Yeah. Now let's just get started for the problem. Yeah. So how can we solve it easily? We're gonna do something about this start URL. We're gonna turn this start URL into an include pattern. So first of all, I'm gonna use maybe, yeah, URL. Maybe I'm gonna call it URL array. It's gonna be start URL dot split. So I'm gonna split it with forward slash. Let me give a random return and just to check what is this URL array. So basically for this URL array, for example, if our start URL is this one, so we're gonna split with the forward slash. So there are two forward slash from here. Yeah, let's just check. what happens for this URL array? Let me just print it out. URL array. Yeah, because this is really easy for us to analyze what is the problem, what happens behind it. Yeah. So if we split it, as we can see, here is just HTTP for the first problem. Yeah. So this is HTTP and empty string. Yeah, because we split it from here, it's gonna be an empty string, and then we have the news.yahoo.com, and we have news and topics, and here, yeah, because this is a split, and for this one, this is just a split, and for this one, this is just a split. Yeah, if we have a double forward slash, you know, inside, we're gonna have an empty string. Yeah, so here there's nothing because we split it according to this one. Yeah, if we have a double forward slashes, you know, we're gonna split it with an empty string. Here for the last one, we want to split it, but from the right side there's nothing. So here we want to split it, but from the right side there's nothing. So that is why in between we're gonna have an empty string. Now we don't need this empty string, but we need a double forward slash, so we just need to replace it. Yeah. So how to replace it? We're gonna replace it like this way. So URL array with index. Let's just check. The index is gonna be index 1, so it's gonna be replaced with a double forward slash. Yeah. Now I'm gonna call this include pattern because everything gonna include this URL. So the include pattern gonna be empty.join with URL array, and it's gonna be from yeah 0, 1, 2. So it's gonna be on 3. Now we have our current URL. If you don't believe it, let me just print out the include pattern. Now you're gonna understand why we're gonna prepare this. Yeah. So this is our include pattern. This is http news.yahoo.com. So this is exactly what we need, because for all the URLs we're gonna need this kind of include pattern. Yeah. Now we are safe to write our BFS. So how can we write the BFS? So we're gonna prepare a queue and wait to the set. Queue gonna be a big queue, and inside it's gonna be the start URL. And similarly for the visited set, it's gonna be a set, and inside it's gonna be the start URL. Yeah. Now we're gonna write the BFS. So while queue, we're gonna pop out the URL. Maybe I'm gonna call it start URL. So it's gonna be equal to queue.pop left, and then I'm gonna get all the URLs. So the URLs are gonna be equal to, here I'm gonna use this HTTP parser because, yeah, you know, this is the only API we are given to use. So we can use this HTTP HTML parser, and we're gonna pass the start URL. Yeah, and what we got is a list of URLs. So we're gonna call it URLs. It's gonna be an array. So inside the array, it's gonna be a list of URLs. Yeah. So this is what we need. So currently we get the URL, and we're gonna loop through it. So for URL in URLs, so I'm gonna check this URL. So if URL not inside the visited set, yeah. So if this URL not inside the visited set, so normally I'm gonna add it to the visited set, and the queue gonna append this URL. So finally, I'm gonna return a list of the visited set. But this is not right. Just let me submit it to check what happens. Yeah, here is a HTTP HTML parser with this method. Yeah, we're gonna use this method, get URLs. Yeah. Now, as you can see, we passed the first testing case, but we didn't pass the second case. This is okay because we didn't use the include pattern. Because of our include pattern, so for this example, it should be, yeah, news.google.com. So here, the news yahoo.com. Of course, it is wrong. We should always include the news google.com. We should not include other patterns. So this is why I designed this include pattern. Yeah. So if we want to put it inside, we have to check this include pattern. So if URL dot start. In Python we're gonna use the starts with. So if we include this pattern, starts with the include pattern, so we're gonna yeah, put it inside the set and put it inside the queue. Yeah, now let me just run it. Yeah, now as you can see, it works. Yeah. Now you can see it passed all testing cases, and it's pretty fast because this is just a BFS problem. So for analyzing the time complexity, because we are not giving anything, normally we cannot analyze it, but this is a BFS problem, so the time complexity is gonna be E plus V. So the number of edges and the number of vertices, but we are not giving such kind of number of edges and number of vertices. So I think even if we don't analyze the time complexity, we are giving something. Yeah. This is URL.length. It's gonna be 100. So this means we're gonna have 100 vertices. URL_i.length. This is 300. This is okay because we are using the weighted set. Yeah, so basically the time complexity gonna be n squared, n gonna be 1000 because this is what given. Yeah, so if we are having like 1000 vertices and they are all connected together, yeah, so this gonna be n squared, n gonna be 1000. So this gonna be the time complexity for the problem. I think that's all about it. Thank you for watching. See you next time.